All right, welcome back. Let's see how this works with some content. I changed some things, angles and whatnot. I'm trying to come a little bit more straight on. I'm trying to change up also lighting, so I'm not going to be washing this out. What I'm using up here today for the next 15 minutes, 10 minutes or so, is our text, and I will give you, at least from the text that I'm using, the page numbers that I'm looking at. Now, what I wanted to do with this, it's what I wanted to get to you on Monday. This is all about histology. Histology, that study of tissues, because we got abruptly cut off. We had some connective tissues that we still had to cover. We had started to dabble with some, but we have more to do, so I wanted to bring you back into it. Remember, when we talked about histology, tissues, which is going to lead us into things like organs and organ systems ultimately, I tried to establish a couple of things that look, tissues are made up of cells, of course. They're also made up of extracellular matrix. We went through, and this is going to be important for Monday, we went through some of the fibers and some of the biochemistry, what holds water, what makes it strong, what makes it bendy. Do we have a lot of cells? Do we have a lot of extracellular matrix? There's all these variables. We spent a lot of time in going through epithelial, and we looked at not just their shape, but what are their functions? Are they squamous? Are they cuboidal? Are they columnar? Are there goblet cells? Do they do secretions? I mean, if you realize that a squamous cell isn't going to do secretion just because of its shape, you're on the right track. That's where I want to go with this. We also looked at some other things that are very unique, like bone, muscle, blood, and blood is a tissue. The extracellular matrix just happens to be plasma. It's not a solid extracellular matrix like you would find in something like bone or cartilage that we'll be dealing with today. So we looked at a lot of those, and we kind of left off, we started to tail off when we got to the connective tissues. And I think I tried to imply, and if I didn't, I'll try and imply it now. Everything else is pretty straightforward. We get a little, not to use the term loose again, but we have a little bit of wiggle room now when we get to connective tissues. So what I want to do is attempt to kind of give you some of the background with connective tissues. Go through loose connective tissue. Got a couple types of loose. Dense, got a couple types of dense. And cartilage, we've got some cartilage as well. So these two pages, let me check the page numbers for you real fast. In my text, it's pages 152 and 153. Now there's a lot of detail on here. Maybe you can't really read this, and that's fine. You have access online. You may have a hard copy of this at your own home. What I want to do is I want to be able to focus on the images, the actual images, the photomicrographs, more than the drawings. And I believe where we tapered off was in loose. So let me make sure we've got all of this. Loose. I believe was maybe the last one, areolar tissue. Now this is kind of an areolar over here. It's a hodgepodge. It's kind of a collect all. I want to look at that, and then I want to play off of that to build some of these other ones. It's got all three fibers, and I may be going a little fast because I'm trying to keep this down to less than 15 minutes. If I can't, I'll make another video to follow up with this one. All three fibers, so reticular, collagen, the elastic fibers made of elastin. Keep in mind what they do. Reticular is like a meshwork, it's chicken wire-ish. Elastin is elastic, it's pliable, it's bendable, it's twistable. And then collagen, really, really strong, doesn't have a lot of give to it. So we find a hodgepodge in areolar of all of these. Lots of vessels. So there's I can't really see much in there that's going to show vessels, but a lot of vasculature, a lot of blood flow in there. So we can have transport in and out of nutrients and waste, and also other cells as well. And if you keep in mind too, hey, what were some of the other chemistries or chemicals that we talked about with the chemistry of tissues? That hyaluronic acid, which is involved in water, essentially water absorption or maintaining or retaining water. So this is, when it comes to areolar as a loose, it's very, it's a catch-all. And like I said, I want to play off of areolar to deal with and build some of these others. The one that you see down here, and I think I was trying to draw this right before spring break, is adipose. Adipose, it's fat. It's this in me. I've got a lot of subcutaneous fat. If you compare this, that we've got a few cells in there, but we've got this whole hodgepodge of other things. If you look here, we've got these really big cells. And so there we have the individual cells. And we don't have a whole lot of extracellular matrix. If you look at the drawing that they've done, the extracellular matrix is in the red out here. And what you see is a whole lot of this yellowish adipose cell. This adipose, or these adipose cells, are loaded with fat. They're loaded with triglyceride. So we use this for long-term energy storage. If you think you're going to go hungry by not being able to go to the grocery store, as long as you have a lot of adipose, you have a lot of nutrient material to fuel yourselves off of. But there's more than just that. It's more than just storage. You're also talking about insulation. The more fat you've got, the more you insulate the internal organs of your body. Also, cushioning. We find protection around internal organs with adipose tissue. So think about that with areolar. What we're doing is we're getting rid of most of the extracellular matrix. We've got this adipose sites. Sites being the cells, so these are the fat cells. So we shift and we go much more cellular. We make them very unique in what they store and what they do. Metabolically, there's not a whole lot more they do. I'd like to make them all fancy, but they're not. So we've got areolar, we've got adipose, and then lastly, with the loose connective tissue, we may have hit this one too, right at the end is reticular. Now, reticular, let me head over here and, there we go on the left-hand side. This is pages 154 now. And 155. Now what I want you to focus on is the reticular fibers. Remember that chicken wire mesh that's in there that you'll find in things like the spleen or the lymph nodes of the lymphatic system. And if you look, this doesn't look like adipose. And it really doesn't look like areolar. But what I kind of like about this drawing, I don't think you can see it well in this micrograph. You can see the cells here, but what's hard to see are these little reticular fibers. And what they've done over here with the drawing is they've really tried to highlight it. So we've increased the amount of extracellular matrix. Primarily, we've shifted over almost to primarily reticular fibers that we find. If you go into a career of studying histology, you can take something like this and break it apart even further. In here, no, we're not. So what I urge you to do is see, how does areolar differ from adipose and how does it differ from reticular? And if you know how they differ in structure, you're going to know how they differ in function. There's this marriage of structure and function that you'll find all the way through AMP1 and AMP2. And we're finally getting to that point. Now, time-wise, I'm watching. We might have to cut out here and do another one of these videos so they are at least downloadable. Let me look at dents. We have two types of dents. Dents essentially comes down to two things, regular and irregular. I'm in cartilage. Hold with me. Maybe that came first. I should have checked this out ahead of time. Didn't. Okay, let me just do that for now. Let me cut back and avoid that for a minute. This is what it comes down to. When it comes down to dents is either regular or irregular. It's an R, as is that. Now, what's the difference between a regular and an irregular? I think it kind of speaks for itself. Also, while we're at it, regular in some cases is called yellow. And irregular connective tissue is referred to as white. Now, the thing that we need to focus on with this, trying to figure out what's the difference between them, it all comes down to one of those all-important fibers called collagen. That really, really, really tough fiber that we have. Now, let me see how I can try and whittle this down, not waste any more time. Yeah, it comes down to this. Regular, all of the collagen essentially runs in the same direction. Looks pretty regular to me. Hopefully it does to you as well. And there's very little elastin in these. Really the main player in dense, regular, and irregular happens to be collagen and what direction they essentially move in or are lined up in. Irregular, I'd ask you right now, if you were all here, how do you think the black lines representing collagen are going to go? And you would probably come up to the conclusion they're going to go in all different directions. And that's right. Regular up here, irregular here. Now, what this is essentially going to do, and this is what I want you to start thinking about, this is going to give a lot of strength in one plane in one direction. I guess it should be in more one direction than a full-on plane. This is going to give me a lot of strength in a lot of different directions. And I've got something in my mind that I'm hinting at with this that will be on the exam on Monday of next week. Where would you find these? Regular? Regular you would find in really tough things like tendons that end up holding muscles and bones together, and ligaments that hold bone to bone. If anybody's ever torn your ACL, you happen to have done damage to regular, dense connective tissue, not like any of the other tissues that we've looked at. Irregular you would find in places like the dermis that we're going to be talking about once I get around to some skin videos. That didn't sound good. In integumentary videos that I'll be putting together when we talk about the dermis, we're talking about layers of the skin. So, regular, irregular, three different types of loose, and actually if you look at them, These are densely packed. These connectives that are loose, they're loose. I don't know what more to say. So try and get yourself around what they look like, and then along with that, what the function is. Now we still have cartilage to go. I'm at about the 13-minute mark as far as I can tell. So I want to cut another one of these that's going to be much shorter. I want to look at 3 different types of cartilage. Also, I want to look at how I'm going to start putting these on YouTube. In other words, how am I going to title them so they'll kind of go in order. Also, I've had a couple of people ask, are these timed like the exam? Are these only going to be up for X number of days? No. Unless I figure out how to take them down, they'll probably be up forever. So no, you've got chances to look at this over and over and over and over and over if you want to. So cartilage on the next video. 2, how I'm going to be organizing and listing these in the next video. And 3, a little bit of an idea of, on the exam, what am I going to be looking for? What do I want you to know about histology? So forget the little paper study guides. I'm going to tell you right now through my fancy iPad. So let me go and make sure this actually ran, and I'll get this online as soon as I can. Oh man. That's actually what it looked like where I was drawing. Sorry, I'll try and adjust that over there a little bit better in the next video. Bye.